Alright, so like I said, today we're going to learn how to solve by graphing, right? So a system of equations involves multiple equations, okay? And we're looking for what we call the solution, okay? And the solution, when we solve by graphing, is where those two equations, those two lines, intersect, okay? So if I'm looking at this example, this has one solution. This has one solution because it intersects at one point right there. So that point is my solution, right? So if the graphs of the equations intersect, then there is one solution, and that's true for both equations. So what do I mean by that is true for both equations? If I was to plug in this point into my equation, it would be a true statement. Right, so if I'm looking at this example here, which is at the bottom of number 4, right, here's my point, negative 3, 1. If I was to plug in negative 3 in place of x, 1 in place of y, that would be a true statement. Same thing here. Okay, therefore it would be my solution. If I plugged it in and it is not a true statement, let's say 5 is equal to negative 2, that's not true, then it is not my solution. Okay, so if I'm looking at the graph and I have two lines that intersect at one point, that one point is my solution to the system of equations. Okay, if the two lines are parallel, which means they have the same slope, if two lines are parallel, then there is no solution, right? Because they never intersect. If they never intersect, then there is no solution to the system. So if two equations have the same slope, that should clue you in that there is either no solution or there could be infinite many solutions. Infinite many solutions. Graham, can you tell me why this one would be infinite many solutions? Where do those two lines intersect at?
The same spot.
Yeah, because those two lines are the same line. Okay, so those two lines intersect right here, 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 as many points as I can draw, or infinite many points. Right, so if they have the same slope, it's either no solution, they're not going to intersect if they have a different y-intercept, or if it's the same line, they're going to intersect infinite many times. So if it's the same line, I have infinite many solutions. So if you're looking and you see the same slope, you know it's either no solution or infinite many. If you're looking and you have different slopes, they will intersect at some point. It may not be on this little bitty graph, but they will intersect at some point if they have different slopes. But if they have the same slope, it's either no solution or infinite many solutions. Okay, so we're going to look today at the graph and tell whether we have one solution, no solution, or infinite many solutions. All right. So I'm looking at number 1. Okay, I'm looking at number 1. It says use the graph to solve the system. Like I said, all our solution is, right? All our solution is where those two lines intersect. So if I'm looking, my point of intersection is right there. Okay, so Andrew, help me out. What is that point? Yeah, so it goes over negative 1 and it goes up 2. So my solution is negative 1, 2. So those two lines intersect at one point. And that one point is right there at negative 1, 2. That is my solution. Okay, number 2. Hayes, help me out. What is that point? Okay, so this is 4, Hayes. This is 6. Right? So it's between 4 and 6, which would be what? 5. Okay, so we got an x value of 5. And we got a y value of, so the point, solution, point of intersection, is at 5, 4. Fantastic. Ryan, you got number 3.
-2, 1.
Absolutely. So I go over -2. I go up 1. Man, this is hard, right? So those are all cases where my two lines, my two equations, my system of equations intersect at one single point. Intersect at one single point. Okay, so part number 2 says, tell whether the ordered pair is a solution of the linear system. Okay, so I'm going to give you two options to figure out if it is a solution or not. The first option is we can graph them just like this. And we'll look and see if they intersect. And if they intersect, is the point of intersection that point right there? The second option is to plug and chug, right? So if I plug in -1 in place of x and 3 in place of y, is the equation true? If it is true, then it's a solution. But it has to be true for both equations. Okay, so I'll show you both of those ways. All right, so on number 4, I need to draw my axis, my coordinate plane. Both of those are not in slope-intercept form, so guess what? We must put them into slope-intercept form, which is y equals mx plus b. So basically what I mean is we're solving for y. So the first equation, I need to get y by itself, which means I need to move this positive x. So we're subtracting x on both sides. I get y equals -x minus 2. Okay, the second equation, we need to solve for y. So Ryan, help me out, wake up. How do I solve for y on the second equation?
Minus x on both sides.
Okay, so I've got 5y equals -x plus 2.
Divide 5 from the y and then do it both sides.
Yeah, so I'm going to divide by the coefficient, which in this case the coefficient is 5, because I want y by itself, so I've got dividing by 5 to everything. I get y equals -1/5 x plus 2/5. Okay, so now I'm going to graph this equation. I'm going to graph this equation. And if those two intersect at -3, 1, then it is my solution. All right, so here we go. So I'm going to graph the y-intercept, which is at -2. And then I'm going to go down 1 over 1. Okay, so down 1 over 1, down 1 over 1. I can go backwards and go up 1 over 1, up 1 over 1, up 1 over 1. So your first equation, why are you late? Why are you late?
My bus never even showed up.
My first equation looks like that. All right, now I want to graph the second equation, so I'm starting at the point 0, 2/5. Okay, so 0, we'll say about 0.5 right there. And then I'm going to go down 1 over 5, so down 1 over 1, 2, 3, 4, 5, plot that point. I'm going to go up 1 over 5, opposite way, plot that point. So looking at my graph, okay, the question asks, is the point -3, 1 a solution? So let's look where -3, 1 is. Go over 1, 2, 3, go up 1, that point right there. Is that my point of intersection? Yes or no? Yeah. Okay, so yes it is. So the first way I could do it is by graphing, just like I did. The second way I can do it is just plugging in, right? So -3 is the x value. 1 is the y value. So we're going to plug in negative 3 in place of x. We're going to plug in 1 in place of y. If both of these are true statements, then it is a solution. All right, so here we go. I've got x, but now x is not x. X is negative 3. I'm plugging that in. So I've got negative 3 plus y is 1. Plugging that in for y. So negative 3 plus 1 is equal to negative 2. Well, negative 3 plus 1 is negative 2. So negative 2 is equal to negative 2. That's a true statement. Okay, so we're good. We're good with you there. Now go to your next one. Plug in x, negative 3, plus 5 times y, 1, equals 2. So I've got is negative 3 plus positive 5 equal to positive 2. Yes. So, once again, we're Gucci. Okay, so if I plug it in and both of those statements are true, then it is a solution. Okay, or if I graph it, and that is the point of intersection, then that's the solution. Then that's the solution. Okay, so what I want to do is I'm going to give you about a minute and a half, 2 minutes. You're going to do number 5 by yourself, and we'll go over it. All right, so if you look at my paper here, what I've done is I've solved both of these for y. I've put them in both in y equals mx plus b form. So the first step to do that is to subtract 2x on both sides. Last step is to divide by the coefficient, divide by a negative 3. So I got a y equals positive 2/3 x minus 4/3. And then I got y equals negative 3/5 x plus 11/5. So same thing. First step is now to add 3x to both sides, because I'm going to do the inverse. And then the last step is to divide by 5, which is how I got a, sorry, that should be positive 3/5 x. Well, that changes everything. Okay. So now I want to graph these. Okay, I want to graph these. So I graph the first one. The first y-intercept is negative 4/3. Plot that point right there, which is a negative 1.33333. From there, I'm going to take my slope, which is a positive 2/3. So I'm going to go up 1, 2 over 1, 2, 3. Plot that point right there. Connect those, and I got that line right there. Now I want to graph this one, right? And so I graphed this wrong, so let me fix it. The first step is to graph 11 over 5, which is about 2.2. Okay, because you're looking at 2 and 1/5. So you're going to plot the point 2.2. From there, you're going to go up 3 over 5, so up 1, 2, 3 over 1, 2, 3, 4, 5. Plot that point. So your line should really look like that. My fault. So this is incorrect. So looking at my graph here, the point 5, 2, is that the point of intersection? Is that the solution? So you go over 1, 2, 3, 4, 5, go up 1, 2. Well, no, that graph is nowhere near close to that point. So you know right now that, no, this is incorrect. That is not the solution. Now, will they have a solution? Absolutely, because, again, they don't have the same slope. This is 2/3, this is 3/5. So they will intersect at some point. Like I said, it may not be on this small graph right here. They may intersect way over here. But they will intersect at some point because you don't have the same slope. They're not parallel. So eventually, those two lines will meet because lines go on forever, right? So the first way is by graphing. Now, the second way is to plug it in, right? And if it's a true statement in both of my equations, then it is the solution. So I plugged in 5, 2 into this equation. So 2 times 5, 2 times x, minus 3 times 2. Here I am right here. Right? All I'm doing is plugging this in. So 5 goes in place of x, 2 goes in place of y. 2 times 5 is 10, minus 3 times 2, which is 6. So 10 minus 6 is 4. Does 4 equal 4? Absolutely. So that's a true statement. But now if you plug into this one, you've got negative 3 times 5, which is a negative 15, plus 5 times 2, which is a positive 10. That gives me negative 5. Well, negative 5 does not equal 11. That is not true. So if it's not true for both of my equations, then it is not my solution. Not my solution. Questions on that one? All right, so flip it over. Look at number 6. So number 6, I have the graph or the equation x equals negative 2. Okay, so again, anytime you have x equals a number, it is a vertical line, because I could say that x equals negative 2, y could equal 0. You got to point at negative 2, 0. I could say that x equals negative 2, y could equal positive 2. You got to point at negative 2, positive 2, etc., etc., etc. So that point, or sorry, that line looks like that right there. It's a vertical line at x equals negative 2. Now we want to graph the next one. The next one's in slope-intercept form, so plot your y-intercept at negative 2. From there, go up 3 over 2. And we want to know, where do those two lines intersect? Okay, well, I need to have a point of intersection, right? So I need to go backwards from this point. So we go down 3 over 2. So down 1, 2, 3 over 1, 2. There's my point of intersection. They need to intersect, right? So I can't just keep going up. I need to know where they cross each other at. So looking at my two lines here, they both cross at that point. They both intersect at that point. So Elisha, help me out. What is that point? I want to know, what is the solution? The solution is where the two lines intersect at, Elisha.
Negative 2 and negative 5.
Absolutely. So go over negative 2, go down negative 5. There's my point of intersection. So my solution is negative 2, negative 5. Fantastic. All right, let's look at number 7. Number 7, I have y equals a number. So I've got y equals 4. Okay, now anytime I have y equals a number, that is a horizontal line. That's the exact opposite of what I had over here. I had x equals a number. X equals a number is a vertical line. So y equals 4 is a horizontal line. We're looking at that right there. Now I want to look at my table, right? So my table, I have 4 points here. So let's go ahead and plot those 4 points. Negative 1, negative 8. Well, that's off the graph. That's down here. Sorry, you can't see that. Okay, but I can plot 0, negative 5. That's that point right there. I can plot 1, negative 2. That's that point right there. I can plot 2, 1. That's that point right there. Okay, so now looking at my graph here, guys, you can find your slope. And you can continue this to your point of intersection, right? So how much am I going up and over between these 2 points? I went up 1, 2, 3 over 1. Same thing here. I went up 1, 2, 3 over 1. So my slope, m, is 3 over 1, or 3. So from this point, I can go up 1, 2, 3 over 1. There's my point of intersection, right? Which again is your solution, right? So where those two graphs, two lines cross, where those two lines intersect is your solution. So Ryan, what is my solution here?
Two, 4.
Almost.
3, 4.
3, 4. 3, 4. Fantastic. All right, so let's go to the bottom. It says, a system of two parallel lines has blank solutions. So if two lines, they have two parallel lines, how many solutions would it have, Riley?
Zero.
Not zero, but no solutions, right? So system that has two parallel lines or the same slope has no solutions. A system of two lines that intersect has one solution. Thank you, Elisha. Right? And that one solution is your point of intersection, right? Is that point where they intersect at. So for the system to have infinite many number of solutions, what has to happen?
Those lines on the same.
Yeah, so they are the same line, right? So a system of linear equations has infinite number of solutions if they are the same line. Sorry. Right, so we have three different cases. We have a case where there is one solution, one point of intersection. Find that point, that's your solution. We have a case where there is no possible solutions because the two lines are parallel, but they're not the same line. So two parallel lines are never going to intersect, therefore there is no solution. And then we have the last case where the two equations are the exact same line. Well, if they're the exact same line, they're going to intersect infinite many times. Infinite many points.